I am Lalita Ishwaran. I am going to speak about Debye Hackle's theory of strong electrolyte. In this video, I am going to speak about the two contents, that is, the need for Debye Hackle's theory and the explanation of Debye Hackle's theory. So, this theory explains the interaction between the ions in the electrolyte solution and its effect for activity coefficient and effective concentration. So it explains about the non-ideality in electrolyte solution, and it gives explanation for the activity in dilute solution, but the accuracy decreases as the salt concentration increases, and this is applicable only for strong electrolytes. And you find that this theory is based on the electrostatic model and a linearized Poisson-Boltzmann model. So Debye Hackle's theory of strong electrolyte is based on three postulates. That is, one is it is for strong electrolytes, two is it is based on the degree of dissociation, and third one is about the ionic atmosphere. So let us look into the detail about it. So Debye Hackle's theory of strong electrolyte, if you take strong electrolyte, அதில் வந்து சாலிட் ஸ்டேட்லேயும் எக்ஸிஸ்ட் ஆகுது, சொல்யூஷன்ஸ்லேயும் எக்ஸிஸ்ட் ஆகுது. ஸோ சாலிட் ஸ்டேட்டில் எக்ஸிஸ்ட் ஆகுறப்ப நம்ம பார்த்தோம்னா சோடியம் அயான்ஸாகவும் குளோரைடு அயான்ஸாகவும் எக்ஸிஸ்ட் ஆகும். பட் சொல்யூஷன்ஸில் எடுத்துக்கிட்டிங்கன்னா கம்ப்ளீட்டாக டிசோசியேட் ஆகிட்டு இட் எக்ஸிஸ்ட் ஆஸ் Na ப்ளஸ் அண்ட் Cl மைனஸ். ஓகே, ஸோ ஒன்று ஒன்றா நம்ம பார்க்கலாம். சொல்யூஷன்ஸில் வந்து சப்போஸ் இட் இஸ் ஆஃப் லோ டயலெக்ட்ரிக் கான்ஸ்டன்ட், தட் இஸ் லைக் எத்தனால், ஸோ ஆர் ஹை கான்சன்ட்ரேஷன், அப்போ என்ன ஆகுதுன்னா இந்த இன்டர்அயானிக் ஃபோர்ஸஸ் இருக்கு இல்லையா, தட் இஸ் த ஃபோர்ஸ் பிட்வீன் த ஃபோர்ஸ் ஆஃப் அட்ராக்ஷன் பிட்வீன் த பாசிட்டிவ் அண்ட் நெகட்டிவ் அயான்ஸ், அது வந்து அப்ரிஷியபிள் அமௌண்ட்டில் இருக்கும். ஸோ எக்ஸிஸ்ட் ஆகிறப்ப Na ப்ளஸ்ஸாகவும் Cl மைனஸாகவும் எக்ஸிஸ்ட் ஆகும். ஸோ இதை வந்து நம்ம என்ன சொல்லணும்னா அயானிக் டப்ளெட்ஸாக சொல்லணும். அண்ட் த எலக்ட்ரோலைட் இஸ் கம்ப்ளீட்லி அயோனைஸ்ட், பட் இட் இஸ் நாட் கம்ப்ளீட்லி டிசோசியேட்டட். ஓகே, ஸோ சாலிட் ஸ்டேட்டில் இல்லைன்னா கான்சன்ட்ரேட்டட் சொல்யூஷன்ஸில் எடுத்துக்கிட்டோன்னா it is in the ionized state. Okay, next coming to high dielectric constant. Now high dielectric constant like water, the electrostatic forces is small. Okay, and if we take very dilute solutions, then the distance between the ions is large. So Na plus Cl minus, it gets completely dissociated. So it is far apart. Electrostatic forces is very weak and intraionic forces is small. Now if the solution is diluted, then what happens is conductance increases. So according to the Arrhenius theory, used a concept for increase in degree of dissociation is used as a method for calculating the degree of dissociation. That is given by the equation alpha is equal to lambda m by lambda m naught, where lambda m is the molar conductance of some concentration and lambda naught m is the molar conductance at infinite dilution. According to modern theory of strong electrolytes, the degree of dissociation or degree of ionization is equal to alpha is equal to 1. This is at all concentration, so it is the not correct for strong electrolytes. So what happens here is Debye Hackle gave a concept, okay, said that increase in molar conductance with dilution is due to increase in mobilities of the ions due to weaker interionic attraction rather than increase in degree of ionization, which is alpha is equal to 1 for all concentrations. So in the same way, decrease in molar conductance with increase in concentration is due to the fall in mobilities of the ions, which is for greater interionic effect. So let us look into what is interionic effect. Okay, so as I said, interionic effect is nothing but the force of attraction between oppositely charged ions. If you take dilute solution of sodium chloride, we are taking dilute solution of sodium chloride. அப்போ என்ன ஆகுதுன்னா சோடியம் அயான்ஸும் குளோரைடு அயான்ஸும் ரொம்ப அதிகமான டிஸ்டன்ஸில் இருக்கும். ஸோ ஃபோர்ஸ் ஆஃப் அட்ராக்ஷன் வந்து ரொம்ப கம்மியாக இருக்கும். ஒரு அயான்ஸும் இண்டிபெண்ட்டாக இருக்கும். ஸோ மொபிலிட்டி வந்து மேக்ஸிமம் இருக்கும், அதிகமாக மூவ் ஆகும். கண்டக்டன்ஸும் மேக்ஸிமம் இருக்கும். ஸோ it will fully contribute to the conductance. Okay, so if the ions are very dilute. Okay, coming next to the concentrated solution of sodium chloride. ஸோ இந்த இடத்துல என்ன ஆகுது, சோடியம் அயான்ஸும் குளோரைடு அயான்ஸும் ரொம்ப பக்கத்தில் இருக்குது. இன்டர்அயானிக் ஃபோர்ஸஸ், inter-ionic force of attraction is not negligible. So mobility of the ions is getting decreased. Okay, so ions வந்து ஃப்ரீயாக மூவ் ஆகாது. So mutual attraction of oppositely charged ions takes place and their contribution to electrical conductance decreases. Okay, so according to Debye Hackle's theory, the interionic force of attraction, not partial dissociation, but the cause is due to decrease in conductance with increase in concentration. Okay, so they derived an equation, okay, and in order to explain about the mobility of the ions. Okay, so here in this diagram, so there are three effects. So Debye and Hackle said that due to these three effects, the conductance decreases for increase in concentration. So one is electrophoretic effect, and second one is asymmetric effect or relaxation effect, and third one is viscosity effect. So let us see the first one, asymmetric effect. If you take solution, it will have negative charges surrounded with positive ions. So this is called as symmetrical ionic atmosphere, so at rest. But once we apply electric field, in that case the negative ions, anions, will move towards anode and the cations will move towards cathode, and you find that this ionic atmosphere is disturbed, and that is called as asymmetric effect. Okay, so it will drag, and as a result what will happen, the conductance will decrease. Okay, so in the next slide, so the asymmetric effect is, if the central ion is positively charged, it is surrounded by negatively charged atmosphere, and when the electric field is applied, the ions are in motion. So positive ions will move towards cathode and negative ions will move towards anode. This destroys the ionic atmosphere, and the ion experiences a retarding force and tends to drag backward, and the movement of ion is slowed, and this is called as asymmetric effect. Second one, let us take the electrophoretic effect. Okay, In electrophoretic effect, the positive ion moves towards cathode. It has to make its way through the medium of water itself, which is moving with the negative atmosphere towards the positive electrode. Okay. Similarly, the negative ions will move towards anode through the medium of water, which is associated with positive ionic atmosphere and moving towards negative electrode. So this counter current slows down the movement of the ions, and this is called as electrophoretic effect. And the third one is viscosity effect. If the viscosity is high, mobility is decreased, so conductance is decreased. Viscous drag of the solvent makes a role on the movement of the ions, which tends to move the direction of the applied field. So electric force is opposed by the frictional viscous drag of the solvent. So in greater the solvent viscosity, greater is the viscous drag, and smaller is the mobility, and lower is the conductance. So here I have shown the electrophoretic effect. So you find that the positive ions is moving towards the cathode, pulling the solvent molecules, and there is a electrostatic retardation force. So Debye Hackles and Onsager gave an equation as lambda c is equal to lambda naught minus 82.4 divided by dt to the power of half eta plus 8.2 into 10 power 5 divided by dt to the power of half lambda naught, and the whole thing is been multiplied with square root of c. So where lambda c is the equivalent conductance at a particular concentration, lambda naught is the equivalent conductance at infinite dilution, d is the dielectric constant of the medium, eta is the viscosity of the medium, T is the temperature, and C is the concentration of the solution. As D and T are constants for a particular solvent, so the equation becomes, its simplified form is lambda C is equal to lambda naught minus A plus B lambda naught. This whole thing is multiplied with square root of C. And A and B are Debye Hackle constants. So that same thing I have given here. So the first part of it is due to electrophoretic effect, and the second part of the equation is due to asymmetric effects. So I have explained about the viscosity effect. So we conclude that the difference between the conductance of the at infinite dilution and at appreciable concentration is a direct consequence of the two electrical forces. In other words, all deviations from ideal behavior are ascribed to electrical interaction between the ions. Okay. So I have given here the terms that are being used in this video. So the meaning of the terms that are being used in the glossary, so one can refer to it. I hope this video was very useful and the concept was very clear. In my next video, I will be adding few more CSIR questions of previous years with the concepts, so that you can relate it to the type of questions that are being asked in the competitive exams. Thank you.